Welcome back to the workshop. We want to continue taking a look at section 4.2, paths and circuits. And in this video, we'd like to take a look at paths. Now, a path on a graph is simply traveling from one vertex to another vertex to another, and so on. So if you could think of vertices as intersections of roads, and you could think of edges as roads. You're just traveling down some roads, and wherever roads meet, that's where you're traveling to next. Or you could think of it highways between cities, like we saw in our first example back in section 4.1, okay, our introduction to graphs. However you want to think of it, a path, again, is simply moving from one vertex to another along an edge, and a sequence of those, right? As far as you'd like to go. So let's take a look at our notes. Now, what I said to you was path. What we can do is be slightly more specific and call it a UV path, not for ultraviolet light, but rather for traveling from the vertex U to the vertex V. So a UV path is an alternating sequence of vertices and edges. You're going from one vertex to another, traveling along a particular edge. So you might start off at vertex V, call it V1, and then you travel along edge 1, and that gets you to vertex 2. Okay, so then you travel along edge 2, which gets you to vertex 3, and you keep going on. That brings you to vertex n-1, to edge n-1, then to vertex n, and then brings you to edge n, and then finally vertex n+1. Now, why do we go to n+1 instead of ending at n? Well, the interest here is in the length. But what you want to focus on in this presentation here is just that we have a vertex, edge, vertex, edge, vertex, edge, which tells us we're traveling from this vertex to that vertex along this edge. So here we're working with vertices that are labeled and edges that are labeled. Now, calling it a UV path would say that this first vertex is the vertex U, and this last vertex is the vertex V. Okay, so it's a UV path. Excellent. Of course, it would require that this edge connects these two vertices and so on. The formalities which seem obvious when we consider an example. Now, the length of a path, length, is simply the number of edges that have been traveled in the path, which is why we use the particular enumeration for the edges and paths, edges and vertices that we do. So edge 1, edge 2, edge 3, edge 4, edge 5, edge 6, or wherever it ends. Okay, that tells us how long the path is. The path is the number of edges that have been traveled, edges in the path. That's the focus there for the length. So if we know how many edges are traveled, we know the length, straightforward, easy. All right, so let's take a look at an example. Here is a path for the multigraph that we've been considering for this section. So we're traveling from R to G, or R to U along G, and then U to V along A, V to U, U to X, X to W, W back to W, then to Y, and then to Z. And the edges tell us along which edges we are traveling. So we're starting at R, and then we go to U along G. That's easy enough. But then when we travel to V, right, here it specifies that we're traveling along edge A. And then we're going to travel back to U, but we're going to do it along B. So we go R, U, V, U, but going from U to V and then V to U, we travel along two different edges. Excellent. So from U, we travel to X, and as it's right, the only way to do that is along N. And look, that's N, the edge that's being traveled. Okay. So we have travel to X along the edge n. Excellent. From x, we go to w, and we do that along p. Excellent. That's the edge that connects it. And then we travel around back to w. And excellent, you'd say, all right, I have to travel a loop then. And there's the loop. Again, the path specifies it, and what we see on the graph makes sense. That's the only way to travel from w to w. And then from w to y along the edge that connects them, which is d in this case. Let's make that a little bit better. That's a little better. All right, good. And then from y to x. So we're going to travel back to x, and that's going to be our ending place. So we did some looping around back and forth that, if all we were interested in doing is traveling from r to x, we could have just gone rux or rzx, and that would be fine. Here we did a loop there, and it came over. Maybe calling it a loop isn't great since this is actually a loop, but we go up and come back, and then go over, up and around and down and back to x. Okay, so that's an Rx path. Rx path. And when we have a multigraph, a path may be given just by the edges in the path. May be given by just the edges in the path. Now, I wouldn't recommend that for a path of length 1. If we were just traveling one edge, just G, I wouldn't know if I was going from R to U or U to R. So I would maybe say that it's U, G, R if we're traveling from U to R. But okay, so let's get what that is, right? If we were to do that here, it would just be R to U along G, and then U to V along A first, and then back to U along B, and then to X along N, and then to W along P, and then back to W along M, and then down to Y along D, and then back to X along E. So that's our path, and it's unambiguous. It is clear what path was taken. But the path may not be given as a sequence of vertices. So the reason that we can't give it as just a sequence of vertices is because I can't. It's ambiguous, right? If I go from R to U, that's okay. That's still clear. But when I go from U to V and then V back to U, I don't know which edge I'm taking to V and which edge I'm taking back to U. So it's ambiguous in a multigraph. And then it's just kind of weird, go from W to W. If there's only one loop there, I guess it would make sense. But the main thing is that when we have parallel edges, by specifying the vertices only, we would not know which edge to be taking when there are parallel edges. Specifying the edges, fine, that works here. Specifying the vertices and the edges always works, perfect. In this case, can't be given as a sequence of vertices. However, if we look at just a graph where there's no parallel edges and no loops, then giving just the vertices would be perfectly fine as well. And in fact, that's the standard to do, at least it will be for us when we're working with graphs. We'll give paths by just the vertices that are in the path. Again, when we're working with a graph instead of a multigraph. All right, so for the path that we've been given, what is the length of this path? Well, the length of the path is given by how many edges are traveled. So we could count these up. Let's do it in green here. So I travel G, and then A, and then B, and then N, and then N, which is our fourth edge, P is our fifth edge, M is our sixth, D is our seventh, and E is our eighth edge. So I can count them up by traveling along the path. That's fine. Or I can look here, 1, 2, 3, 4, 5, 6, 7, 8. Or I could look here, 1, 2, 3, 4, 5, 6, 7, 8. Right? No matter which way I approach it, I find that there are 8 edges traveled, and the length of the path is 8. Excellent. So let's give another Rx path of a different length. So we're just looking at visiting a different number of, or traveling along a different number of edges. So let's do something that's a bit different here. So let's start at R, but then let's go along H to Z. And we'll make it at least a little bit fun here. So let's go from R to Z. So R to Z along H. And here I'm going to give it as a sequence of vertices and edges. So we'll go from R to Z. And then let's see, let's go to Y. So along I, I'm going to go to Y along I. And then let's go to W along D. So along D, we'll head to W, and then from there, we'll actually go right to X along P. Excellent. So there's a different path of a different length. If I wanted to double check the length, of course I can do that. I can either go along here and observe that it's 1, 2, 3, 4 edges, or I can count them here, 1, 2, 3, 4 edges. So the length of this path is, this path has length 4, because we've traveled along 4 edges. Excellent. So a UV path, length of a path, and then how to specify them on a multigraph using the edges. So that's all that I wanted to talk about for this video. So we'll be back in the workshop very shortly to continue taking a look at section 4.2. So I'll see you guys soon.